welcome everybody. Thank you for joining Soligent's webinar on EV charging. I'm joined today by Tony Vernetti. He is the senior trader at Enphase, and he's going to walk us through the key differentiators and benefits of the IQ series of EV chargers for Enphase. A lot of you haven't met me. I'm Chris Wahl. I am the business development manager on the EV charging side, and I oversee the entire lineup of EV chargers here at Soligent. We hope that you'll limit distractions today in our webinar. We just asked for 20 minutes of your time, and hopefully adding to your learnings and your development will enhance both your sales as well as this year's opportunity. So without further ado, I want to pass it over to Tony. Take it away. Thanks so much.
All right, thanks for the introduction, Chris, and thanks to all of you out there who decided to view this training. I hope you come away with some useful information about our latest and greatest EV charger called the IQ EV charger. So what I'd like to do is actually just lay out a few learning objectives for today's session so we know what we're getting into. After this session, you should be able to do these three things at a minimum. Explain the benefits of integrating an IQ EV charger into an Enphase energy system. Explain how the IQ EV charger with an Enphase solar system can charge an EV solely with excess solar power. And explain how the feature Storm Guard ensures a fully charged electric vehicle if there's a risk of a weather-caused outage. So I'd like to start actually by just going over what I mean when I say Enphase energy system. It goes back to the history of Enphase. When Enphase was founded in 2006, all that we did at that time was manufacture solar microinverters. But the company was named Enphase Energy as opposed to Enphase Solar or Inverters because it was always the vision of the company to develop an Enphase or an energy management system that was much more comprehensive than simply solar energy production. The Enphase energy system is comprised of the components that you see on the slide here. We have microinverters on the solar array and in our batteries. Our battery storage system, the current generation is called the IQ Battery 5P, and then now the IQ EV charger as well. Since the IQ EV charger is a Wi-Fi connected device, it communicates and can be controlled by the Enphase system. And this is really important because it maximizes the financial benefit for the homeowner. And it's all monitored in one place, the Enphase app, as opposed to a homeowner having a different app for their solar, maybe a different app for their EV charger, and maybe even another one for their battery. With the Enphase system, everything can be monitored and controlled in one place. Electric vehicles are much larger electrical loads than most people really quite realize. It's likely the largest single energy consumer in your typical home. And with the increasing complexity that we're seeing with utility rates, especially in places like California, it's more important than ever for EV charging to be actually integrated or incorporated, as a different way to say it, into an intelligent energy management system such as the Enphase system. Most other EV chargers on the market today have either simple schedules to charge an EV during the lowest cost periods or no programming at all. This approach is insufficient to maximize savings for EV owners who also have solar, leaving a lot of money on the table for many EV and solar system owners. So let's dig into the technical details of the IQ EV charger. It is both Bluetooth and Wi-Fi enabled, allowing for either direct connection with a smartphone or tablet, or to the Enphase cloud for integration with an Enphase energy system. It comes in 4 different models with charge current, or charge power rather, ranging from 32 amps to 64 amps. The model number actually indicates the circuit breaker rating for that charger. So for example, the first column there, the IQ EV charger 40, charges at a rate of 32 amps. And the 80 on the far other end of the spectrum in terms of speed charges at a rate of 64 amps of continuous power or continuous current. Very few of our competitors offer charging at the fast rate of 64 amps. And in the past year or 2 years, a lot of the EVs that are hitting the market tend to have faster charging capabilities for one, and also they're often larger vehicles with larger batteries. So a charger that can supply 64 amps mean they can charge their vehicle at twice the speed compared to a 32 amp charger. But for most EV owners that drive sedans that are relatively efficient in terms of their fuel economy, can certainly get by with a 32 amp or 40 amp charger. So that would be the 40 or the 50, which are the models that Soligent carries. They're by far the most popular and usually can be installed on a service panel without the need for a service panel upgrade as well, depending on the loads of the home, of course. For the average electric vehicle, the IQ EV chargers can add between around 28 to 56 miles of driving range per hour of charging. And again, that does depend on the charge power of the model, as well as the acceptance rate or how quickly that electric vehicle can charge. They come with 25-foot ruggedized cables with a J1772 connector. Now, this is the most common connector. Nearly all electric vehicles, in fact, as far as I know, all except for Tesla that are produced today have a J1772 connector. So it's kind of the universal connector today. However, it is being likely going to be replaced in time by the Tesla connector, which is actually called the NACS or NACS connector. And to prepare for that, Enphase is going to be offering our line of chargers also with the NACS connector starting next month. But the currently available models have the J1772 connector. And also do want to point out that all vehicles that have the other type of connector always come with an adapter, so they can charge at any charger that has the J1772. So in a nutshell, any vehicle can be charged with an IQ EV charger. The 25-foot heavy-duty cable is designed to withstand a lot of abuse. Oftentimes, cables are accidentally left on the floor and driven over by the vehicle, so they're designed to really withstand a lot of wear and tear over the years. The long 25-foot length is actually the maximum length allowed for EV chargers, and it makes it a lot easier to reach multiple vehicles within a garage. They have an industry-leading 5-year limited warranty, whereas most chargers on the market have only a 1 to 3 year warranty. And cable management is really easy with this device because it's built into the unit. The top of the unit kind of looks like a saddle when you look down on it, and the cable simply wraps around the unit itself. It also comes with a wall-mounted holster for the connector, which is kind of a cup that faces down, and the connector goes into it, and it's protected from the elements like rain and snow if it's installed outside. All 4 models are available in a hardwired option, which is probably the most popular option. That said, the 40 and the 50 also come with either a NEMA 1450 plug or a 650 plug as options, as these are receptacles that are very common in homes and may already exist. And the homeowner might like the idea of plugging their charger into a receptacle so they could potentially maybe take it with them in the future if they move. As I mentioned, they have both Wi-Fi and Bluetooth connectivity options. They're designed to be able to be commissioned and configured by the homeowner in only about 3 minutes with the Enphase app, the free app for homeowners to monitor their systems. They also have ETL safety listings. They are Energy Star rated, so they consume hardly any power when they're not actually in use charging. And the enclosure is NEMA 4 rated, so that again means it can be installed inside or outside. I do want to point out one detail about the IQ EV charger because we do always get this question when we give our training. Is the IQ EV charger a bi-directional charger? So the answer is no. However, Enphase is developing a new charger that's going to be coming out next year, which is bi-directional. Bi-directional simply means that not only can the charger be used to charge the vehicle, but it can also be used to extract the power from the vehicle to potentially use it in the home or to export to the grid. Again, that's a feature that we're working on that's probably going to come out next year. But the IQ EV charger is a smart charger, and we're going to go into those features, the unique features that it's capable of in the next couple slides here. Since the IQ EV charger is connected to the Enphase cloud, the owner can use the Enphase app to select their preferred profile or operating mode for their energy goals. The first is savings mode. So homeowners who don't have solar will likely just leave the charger in savings mode, which will allow them to easily select their utility and their electric rate from a drop-down menu, and their vehicle will only be charged during the least expensive off-peak time period. Most chargers require the owner to manually enter the time periods for charging, which is sometimes hard for owners to find that information. So we try to make it easy by simply providing a drop-down menu. If a customer has an Enphase solar system, they can actually also select what's called self-consumption. And the system will automatically charge their electric vehicle with any excess solar power to maximize their carbon offset. The charge power is dynamically controlled in 25% increments of the power rating to closely match the amount of excess solar power. And I've got a couple more slides on specifically about self-consumption mode, because that really is one of the greatest features about the IQ EV charger. The next mode is full backup mode. Full backup ensures that the system with IQ batteries will remain fully charged in preparation for grid outages, and the EV will also be charged with excess solar power. And lastly, Storm Guard. Storm Guard is not an operating mode, but it is an option that can be turned on if the system is in either self-consumption or savings mode. With Storm Guard, Enphase basically monitors alerts from the National Weather Service, and if a system is set to Storm Guard on, it'll switch systems to full backup if there's a risk of bad weather knocking out grid power in that region. And basically this immediately fully charges the battery and the electric vehicle. And the user can even put in additional custom schedules so that they can make sure that their vehicle is always going to be fully charged if they would like it to be fully charged for their departure time. One example for that is if the system is in self-consumption mode and say the battery is nearly fully depleted and they need to fully charge their vehicle during the day. If they leave it in self-consumption mode and it's a kind of a cloudy or overcast day, they might not be able to actually fully charge their vehicle because it'll be charging at a slower power rate. So a custom schedule could be set so that the vehicle will then charge at full power for a specific period of time to fully charge that vehicle. So here we've got a couple simple animated slides to illustrate how self-consumption mode works. So again, the concept of self-consumption is to charge an electric vehicle from solar generated power only. A good example is in California, where we have the solar billing structure called NEM 3.0. California has very high electricity rates, even for the off-peak period. So it's relatively expensive to charge a car. Not as expensive as buying gasoline, but it is more expensive than most other states. With NEM 3.0, there's also very little value to sending solar energy to the grid. And that applies to some other states as well, where net metering has perhaps changed over the years and customers don't get much credit for exporting energy to the grid. So that means there's a lot of value to being able to store that excess solar energy in the electric vehicle's battery. So how is the EV charger able to charge an EV with excess solar power? It's possible because of the all-in-one nature of the Enphase system and the monitoring of both energy production and energy consumption by the system. So that means that at any moment, Enphase knows exactly how much excess solar power is available. And the IQ EV charger will automatically adjust its charging rate to ensure that the EV is only charged with excess solar and doesn't buy any expensive and dirty grid power. Now, obviously, this scenario does require the car to be plugged in at home during the day, so it's ideal for an EV owner who works from home either part-time or full-time. And even works on a cloudy day. So on cloudy days, of course, solar power output is going to vary throughout the day. So the IQ EV charger is going to constantly be monitoring that. Again, doing that calculation about excess solar power and adjusting the charge rate so it doesn't even pull power from the grid on a cloudy day. Now let's compare what we're just looking at to a generic smart charger or the type of charger that can be programmed to charge only at certain times. A homeowner that has solar might program their charger to charge during the middle of the day, assuming that on a sunny day, their vehicle is going to be fully charged by solar energy. The problem is that a typical electric vehicle charger is still going to charge at the maximum, is always going to charge at its maximum speed and highest charge power. The amount of power consumed by the charger is likely to far exceed the amount of solar power available for the home. So some of the energy will come from solar, but a large portion of the energy needed to charge the EV will be purchased from the grid at relatively high off-peak rates. So this is where the true benefit of the IQ EV charger, being able to charge a vehicle with only solar power, comes into play. And customers can easily see that their system is set up properly and is charging the electric vehicle only with solar power by checking the app here. This is the live status screen of the app. And you can actually expand the consumption view, the little icon for the home there, and it shows you exactly how much power the home is consuming and how much power the electric vehicle charger is consuming as well. In this example, this is actually my home. I've got the 50, which charges at 40 amps, or equates to 10 kilowatts at a maximum. So this charger is actually charging at 25% of its full power rating at the moment. And the customers, if they go to the energy tab, if they want to see energy consumption for over a period of time, this is what they'll see. So this is on a given day, shows energy production above the horizontal x-axis line, and then energy consumption are the bars below. And specifically the electric vehicle consumption is the line below that's basically going over those bars. So here you kind of see graphically that the charger is constantly adjusting its charge rate. Now, while some benefits are available from the IQ EV charger that really apply to customers that only have solar systems, the IQ EV charger is also a great option as a standalone device. The standalone charger can be set to Storm Guard, even though there's no solar or battery. This customer sets it to Storm Guard. That means if there's a storm approaching that might knock out grid power, that electric vehicle will be fully charged and ready to go for that customer. And regardless of whether the system is standalone or has solar and batteries, of course, the system can be controlled with the Enphase app. Prioritize EV charging during off-peak hours. So again, this is available for standalone and chargers with solar and batteries. If the customer wants to charge their electric vehicle with excess solar, of course, that's not possible with the standalone IQ EV charger, or for that matter, if it's connected to a solar system that's not Enphase. Enphase can't talk to other solar systems and adjust the charge power of theirs. Enphase can only control an Enphase system. And then charging an electric vehicle during an outage. Of course, during an outage, you're not grid connected. So the only source of energy that you could use to charge the car would be a battery. So that configuration or that feature would require a battery. And I kind of jumped ahead a little bit at the beginning there. So we already covered Storm Guard. Storm Guard can be used whether it's a standalone charger or with solar and a battery. And that actually concludes today's training. So this is designed to be a condensed, concise training. We have additional trainings on our website if you'd like a longer form or like to learn about our other products. But again, today was focused on the IQ EV charger.
Tony, thank you so much for walking us through that. What's amazing as well is that we'll be sending out both spec sheets as well as installation guides, and make sure that you circle back with your account manager with any questions. And we're really happy to have Enphase as an incredible partner. And once again, thank you, Tony, for taking the time, and thank you everybody for hopping on and joining us today.